Lesson 12.8. This is an application problem with variation. This is one of the more challenging types of problem in this lesson. As you're doing this, I would always recommend, first time through, if you're not sure how to do it, go to Tutor, go to Solution, write out the problem, get a real good understanding, back to practice, and then try similar. 9 times out of 10, you'll get a slightly easier problem, and you will have just written down the problem. So you can then apply what you just learned. With this, as you learned in the lesson, there is a constant of variation k. For me, the trickiest part is getting in the habit of knowing where to put the constant of variation k. All right, so the safe load L of a wooden beam supported at both ends varies jointly as the width, the square of the depth, and inversely as the length. Okay, so L is going to be equal to, it varies jointly, so you have your constant of variation, and jointly we're going to multiply times W, and then we're going to square a D, and then inversely means over L, which is little L, length. Okay, then they give us some information, and the first step we're going to do here is find what the K is. They also do tell us that the L will hold up to 7,172 pounds. Okay, so let's replace our values. We have 7,172. We're going to figure out what K is. They've given us W as 5. D is 7, and we have to square that, and we're going to divide that by 13. Okay, so now we have 7,172 equals, and basically when you take 49 times 5, you get 245K divided by 13. Now, here's the part of this problem that's really important. You don't want to go decimal on this. Let's keep it as a fraction. So I'm going to multiply top and bottom times 13 over 245. Okay. So I will have K on a side by itself. And what I'm going to leave up here is I'm going to take 7,172 times 13, which is going to be equal to 93236 divided by 245. And I'm going to keep that. I'm not going to go decimal. Sometimes it makes your problem slightly off. Okay, so now that I found the K, now I can go on to the second part of this problem. It says what load, so big L, what load would a beam 3 inches wide, 3 inches deep, 18 feet long of the same material support? So we're going to use our constant of variation, and we're going to use our equation up here. So for little k, we're going to put in 93236 divided by 245 times the W, which is 3, times the D squared, which is 3 squared. I'm just going to, well, I'll put 3 squared, but that's, and then we're going to divide that all by 18. So this just becomes an interesting calculator problem. And here's how I did it. 3 times 3 squared is 9. 9 times 3 is 27. I took 27 times the 93236 number. Then I divided by 245. Okay, so again, in my calculator, I took 3 times 3 times 3 times 93236 equals. Then I divided by 245. Then I divided by 18. And you get, your final answer is 570.8, I believe. And it says round off to the nearest pound. So this becomes 571. And that is your answer.